So we're going to have a look at the work that we did in National 4 on working with right-angled triangles. You have previously met Pythagoras' theorem and also met trigonometry, which you have learned to use with right-angled triangles. We're revisiting this work so that when we start the National 5 work on triangles, which includes work on non-right-angled triangles, you will be confident with your National 4 work, and that will help you make the progress with the National 5 work. So, to look first of all at Pythagoras' theorem, just a quick reminder that we use this in right-angled triangles. When we've been doing the National 5 course, you've met this. You've had to be able to apply your knowledge of Pythagoras' theorem within the circle context, questions where you've had to work out the or usually form a right-angled triangle and then do a calculation that might involve working out the depth inside a container. So we're basically, with Pythagoras' theorem, looking at how the three sides of a right-angled triangle connect, and you get this rule that says the shorter two sides, when you square them and add them together, they're always equal to the longest side squared and added together. And of course, longest side has got its own special name. It's called the hypotenuse. So there are two kinds of calculations that you do with Pythagoras. Sometimes you'll do an add, sometimes you'll do a subtract, depending on what it is you're trying to work out. So if you are trying to calculate the longest side, the hypotenuse, then you will certainly be carrying out an addition where you will add the two sides that you already know. If you're trying to calculate one of these shorter sides, then you will actually be subtracting with it, starting with the hypotenuse squared, take away the other side squared. So that's what using Pythagoras is about, and that works in right-angled triangles. Something else that works in right-angled triangles that you met before is trigonometry. And trigonometry doesn't just look at connections between lengths, which is what Pythagoras does, but trigonometry looks at lengths and also sizes of the angles inside the triangle. And again, at National 4, we're specifically looking at right-angled triangles only. However, our aim in National 5 is to progress on to non-right-angled triangles. So, with a right-angled triangle, it's important that you know how to name the sides, and the hypotenuse we've already spoken about. That's introduced when you do Pythagoras. But because we're now also considering angles inside here, so for example, you might have this angle that I've got marked here with the A and the star. If you do know this angle, then the other two sides can be given names relative to that angle. So the side across from that would be referred to as the opposite side, and therefore the side next to that angle would be the adjacent side. So when we're dealing with right-angled triangles and we're dealing with angles and lengths, then we can talk about opposite and adjacent. I will shorten these terms, and when I'm labelling my triangles, I will use ADJ for adjacent, and I will use HYP for hypotenuse, and I will also use the first three letters, the OPP, for opposite. So when you move on from that, you should know that there are three trigonometry ratios that can be used to calculate length of a side, or in fact the size of an angle. And this is a little memory aid down here that you can use to help remember how they are connected. The SOHCAHTOA, where the S stands for the sine function, and your O and your H are to do with your opposite side and your hypotenuse side. Your cos ratio, you will use that when you're working with the adjacent side and hypotenuse side, and your tan ratio, it uses the opposite side and the adjacent. So remembering this little, almost like a little fancy word that you should try to remember, SOHCAHTOA, but know what each of the little ratios stand for. So we're going to use that. You've met this before, but this is us just revisiting it. Whenever you're doing any of these questions, I'm looking for you to sketch the triangle, mark on the triangle what information you know. So here, got a right angled triangle, clearly got marked in where the right angle is. We've got an angle inside, we've got one side, and we're trying to calculate this missing side here. So clearly, first thing we want to do is label. So right across from the right angle, we've got the 6.2, and that is my hypotenuse. So I know the hypotenuse. I've got this other marked angle here, and the other side that I've got something or information on is this, where I've got this x that I'm trying to work out. Now that relative to that 57, that is the opposite side. So if I'm looking at my ratios, and I'm going to look for the ratio that links the opposite and the hypotenuse, so that would be this one here. So opposite and hypotenuse, the hypotenuse we don't know, but that's what we're trying to work out. So that's the one we're going to be using that links the opposite and the hypotenuse. So what I'd write down for that, I would write down my formula that says sine of the angle, A, capital A for angle, equals opposite over your hypotenuse. And what I'd then be writing down is my angle is 57, so sine 57 equals my opposite side, that's the x, and the hypotenuse is the 6.2. Now what you've got there is an equation. It's an equation which has got a fraction in it, and when you're dealing with equations with fractions, you want to be able to get rid of that fraction. So in order to do that, this is dividing. So if I multiply each side of this equation by 6.2, I'm just going to rewrite this on the next line. If I multiply the equation on both sides by 6.2, so I'm going to write that down again. So sine 57 equals x over 6.2, and just show you that if I times here by 6.2, I would be able to cancel the 6.2, and that would get rid of my fraction. But of course, if I multiply by 6.2 on the right, I'll also need to multiply by 6.2 on the left. I'm now just left with x here, so I'm going to write that x on its own. So x is equal to, I'm sort of switching it round to write it like this, 6.2 times sine 57. You do that on the calculator, making sure your calculator's set on degrees. If you do that, you get the answer of 5.1990, a whole load of other digits. You were asked to round to 2 decimal places here, so rounding to 2 decimal places. That's your first one, that's your second one. That would be, you use the third one to help you. That of course makes this one go up. If you make that go up, that becomes 20. So we get x equals 5.20 would be your answer to 2, and we'd have centimetres in there, and that would be it rounded to 2 decimal places. So key thing when you do this, it's important that you pick the right ratio, and you need to draw the diagram and label your sides so that you are picking the ratio that you want. And that's how you go about working your way. You're trying to rearrange this equation to get x equals on its own. So if there's any fractions like that, you want to multiply to get rid of those fractions. So, second example. Right, this time, there's my right angle, but I don't know the hypotenuse across from it. Don't have it, not trying to find it. So I'm just going to leave the information off of that. However, I'm now going to use this x and say this side here is opposite to that x. And because I know that this side here is my hypotenuse across from that right angle. This other side here must be my adjacent side. So the two sides that I'm going to be working with are the adjacent and the opposite. So looking through your ratio, sine uses opposite and hypotenuse, cos uses adjacent and hypotenuse, and tan uses opposite and adjacent. So it's going to be this one here. So you're going to begin this question by writing down the general formula, which is tan of the angle equals opposite side over adjacent. Now this time I don't know the angle, that's what I'm trying to work out. So my angle is where my x is going, so tan x equals my opposite side is 9.4 and my adjacent side was 13.8. Now when it's the angle that you're working out, your working is a wee bit different. What you need to do here to work out your angle, so you write down x equals, and this is where you have to do what's called the inverse tan, where you have to do shift and then the tan button. Right, so two keys to work with here. Shift tan brings up tan to the minus 1. Put your fraction in, 9.4 over 13.8, and that will bring you up the angle. So when you're working with an angle, it's always going to be this shift tan or shift cos or shift sine. So we end up with 34.2611 whole of the other digits, and here we are rounding to 1 decimal place, so your answer here would be 34.3, and this is degrees, so we need to put the degrees in because it's an angle and we were only rounding to 1 decimal place. So notice the difference between the two types of questions. They do both start off with trig ratios and it's about picking the right one, but this one over here, when you're trying to find a side and you're trying to isolate the x equals in your equation, you are multiplying to get rid of that 6.2 that's been divided, whereas this here, because the x is the unknown and it's beside either the sine, cos or tan, you will need to do this step where you're doing the inverse button on the calculator to get the angle. Right, one last one. Again, triangle needs to be drawn. You name your sides, so there's your right angle. Across from your right angle you've got the hypotenuse, and clearly this is our angle here that we have, the 78. This side over here would be opposite, but we don't have it. However, we do have the one beside it, which is the adjacent. So you're therefore looking at what ratio uses adjacent and hypotenuse. So adjacent and hypotenuse would be the cos ratio. So you would write down cos of angle equals adjacent over hypotenuse, and you're doing cos of 78 equals your adjacent side is 6 over your hypotenuse is x. So again, we've got an equation that we need to rearrange. We've got this, we are dividing by x. So the thing to do here to get rid of your fraction, you do the opposite of dividing by x. You are going to multiply by x, and you are going to multiply by x on both sides. When we multiply by x over here, these x's will cancel. So what we're then left with is x times cos 78 is equal to, and we've just got 6 times 1 here, which is 6. Now on this side, we want to isolate the x. We've got an extra step to do this time because that x is getting multiplied by cos 78. So the opposite of multiplying is to divide. So what we then need to do is 6 divided by cos 78. So you're really dividing by cos 78 on both sides, and that gets you down to that step there, and you get x equals 28.25 8584 and if we're rounding to 2 decimal places, that would be 28.86, and it would be centimetres for your length. It's a wee bit tricky sometimes when you're having to rearrange your equation. So now it's your turn to practice in the textbook.